So in tutorial number 2, we will now vary one input parameter manually. So that's one of the advantages of a semi-analytical model, that we can just vary input parameters and very quickly see the effect. So I am back in our A-SLOTH folder, and we want to change now the max, the maximum mass of the population 3 IMF. So first we run our fiducial model. And for this, let's be safe and do a make clean, just in case that maybe you've changed something, and make again. Depending on your setup, this make clean was not necessary, maybe not even the make, but just that you see how it usually works. And then let's run the model again with para template. And so now we need to keep track of this output folder name. And now we wait until the code has finished. Okay, A-SLOTH has finished. Now let's rename this output folder to keep track. So in our fiducial model, we ran with max of 210. So let's rename. So this folder name to, let's follow the tutorial, output max 210. Okay. Now we want to change this value, so we change the parameter file. However, we do not want to change the parameter template, because that's our fiducial values that maybe we want to remember. So let's copy the parameter file to create a new file with max. And now we can open this new param max. Here you see all the parameters that are set in A-SLOTH. And now we want to change it to, let's say, 100. So what if all POP3 stars were at most 100 solar masses? Now we save and exit. And because we only changed the parameter file, we do not have to recompile the code. So we can directly run A-SLOTH with the new max. And we can wait a little bit and just confirm that our new value, max of 100, is now taken into account. Currently, the merger tree is generated. It should only take a few seconds. And there we are. Now we see the POP3 IMF goes from 5 solar masses as before to 100 solar masses, as we just said. So again, let's wait for the code to finish. And the code has finished. So now we check again the name of the output folder. We move it to a new name. Now it was max 100. And we do it the last time with max 300. So let's open our parameter file again. Let's set this to 300, save, and run the code again. And let's wait for the code to finish. And we ran the code with max 300, and it has finished successfully. So let's also rename this output folder to max 300. And now we should have 3 output folder, output 210, 100, and 300. Now we want to plot the results, and we also provide plotting scripts for this. So let's open the plotting script. And scroll to the bottom where we have the user folder. So here we need to specify the folders that we want to use for plotting. If you have renamed it the way we did in the tutorial, we can also just copy paste. And we can also use user labels here that maybe tell us what we changed. So again, we can copy paste those. You also should deactivate the plot newest folder false. Otherwise, it will just plot some additional things that maybe we don't want. We save, we check, was there anything more? No, we changed user folder, user label, and now we can run the script. So I go out here and I run it again with Python 3. And now it told us the plots will be saved in output max 100 plots. So let's copy this, change directory here, and see what we have. And again, we have some plots that we can display. And there we go. We see the metallicity distribution function generated from A-SLOTH, but with different assumptions of the maximum mass of the POP3 IMF. And we see it has an effect on the low metallicity tail of the MDF. And that was tutorial number 2. Thank you very much.